Okay, the complimentary 3 minutes has expired, so we might as well get on with it. Good morning, everybody. Okay. I'm going to go back here to this. Oh, come on, why is this being difficult? To this particular picture, which I've shown you numerous times. Physical database, logical database, which is the topic that we are going to cover today. The trigger programs, which you've dealt with in a great deal of detail, and the I/O services, which we finalized pretty much at the end of the last session. I've had no questions via email as a result, unless they've been in the last hour. I haven't looked in the last hour, I must admit. And I haven't got my email open, so I can't tell. So the I/O services we've pretty much dealt with. If there are any questions that I can take up later, with the greatest of pleasure, send them to me. And before we get on to look at the logical database today, I just want to introduce the concept of enterprise services. Enterprise services are the layer that provides non-database functionality, generally speaking, or database functionality across multiple physical tables, and also provides services to the application side of the system, of the application. So enterprise services are something that is developed by the teams, generally in conjunction with the database people, to be able to provide packaged services for delivering functions to the application code. The typical example, which I think I've used on numerous different occasions, are tax calculations, quantity discount calculations, all of these things which actually are used in different parts of the application for different purposes. They should be consolidated into enterprise services. So enterprise services sit on the fence between the application code and the database. The database is defined at the I/O server level, this level here, and the enterprise services sit sort of between the two. You'll notice the enterprise services, let me just get a pointer option and give myself a pen. You will notice the enterprise services communicate with I/O servers. Pretty much any database activity that the enterprise services are doing should be done directly through the I/O services, but I have provided arrows for access to the logical databases and directly down to the physical databases as well. So that an enterprise service, because it is a procedure inside a service program, and is thereby controlled by the service program, and again, the adoption of owner authority, can, if it's necessary, access the physical and logical database directly. I tend to avoid that personally myself. I rather expand the I/O services layer and do all my communication with the database through the I/O services layer, even for the enterprise services. It's a better form of protection. There are a couple of other things. Oh no, I took out those arrows. So the enterprise services can also, the arrows are gone, but they can typically, these these arrows are typically read rather than write. And they can be embedded SQL, i.e. the enterprise services can do fancy footwork with blocks of data to provide that service to the application. So that is the enterprise service. Now, the enterprise services at that level, half in and half out of the database. Again, like I explained with the I/O servers, the parameter structure should be consistent. Now, I think I'm going to have to just exit this. Sorry, just bear with me for 1 second. I just want to clean up here, and I want to get hold of a green screen and the RDP. I've got RDP, but I need a green screen as well just to get that in place. I'll put it out of the way. Sorry about that. We will get back to this. Right. I'm just checking the recorder. And I think the recorder is actually on. Yes, it is. So that's fine. Sorry, guys. I rushed up to the last minute, so I'm a little bit... Okay. We're talking about I/O services. Now, when I discussed I/O services with you, and I discussed the logic, the parameter lists that one should try and keep as consistent as possible. I'm going to just open a source code for an I/O server, just so that we can see what I was talking about at the time. My I/O services, as I explained, have essentially evolved to a 3-parameter set. Now, when you get to the enterprise services, it's a little more difficult because enterprise services can request an assortment of parameters and provide an assortment of results depending on the actions that are required. Now, this means that your choice of parameters is going to be a lot wider and a lot more complex than the I/O service. However, I want you please, and I'm not going to read this for you, but I would like you please to have a look at this manual. I carry it. It's the APIs. I'm not sure how many of you are familiar with APIs on the system. Let's pick one that I'm fairly comfortable with, object APIs. The object APIs, all APIs in fact, within the IBM API structure, pretty much depend on the same sort of thing. If we use a list objects and we have a look at the list objects, the way they work is that you would have some input parameters in a required parameter group. And one of those parameters is invariably a format name, i.e., the format name is an ID, which indicates to the enterprise server, or to this API in particular, this is a list objects API, the information that you want the API to return to you. And if we look at that, you will see that this one has a number of different formats that will return different sets of information. They all relate to an object description. Please don't make the mistake of having an enterprise service that provides information from all sorts of different places all over the database. That is not a good idea. Your enterprise service must focus on a specific aspect and use formats to provide different types of feedback. For example, the first one you can see is the fastest. And thereafter, the information that is returned gets larger and larger and larger and larger. It's a very nice technique. It means if you want the minimum data, like, for example, a customer's name and address, you, in this particular case, where are we here? That's the input parameter section. There is the list data section on that format. And you can see object name, library, and type. That's all that's returned. Based on the input parameters, that's what you get back. So that's the fastest way and the least amount of information. Your different format names, your different formats will then deliver to your application different sets of data depending on what has been asked for. And generally speaking, the more formats there are, the bottom ones provide more information. They might stretch over a number of physical files to gather that information. They might even run embedded SQLs to pull information out and make it available to your application. So this technique is very common for list objects. And the result is usually placed in a qualified user space object. Now, a user space object we will talk about later on because it's one of the greatest things that is ever available, and it will happen in the second half of this course. The output often comes back, list of list objects comes back in a user space, or it can come back as a pointer or a structure, whatever you choose. But it should be a fairly consistent style of operation. So that at least, even though the enterprise services may offer services on different sections of the database, and they may offer small to large different returns, at least they should operate almost all within the same type of parameter structure, which typically would be a return space, a format name, and then input parameters to define what you are actually calling. Notice here with the APIs, we have optional parameter groups. There are 3 of them in this particular case. And these conform to exactly what I said about service programs. You never change the parameter list of a service program. You always add new parameters to the bottom of the parameter list, and you make them optional. And as in this case, this is what the APIs in the IBMI do. That was added after this API was released, so it was added as an optional parameter group, and if you don't provide it, it doesn't crash. Then again, there was another update. So basically, there have been 3 changes to this API that have required additional parameter information, and that's how they do it. So that existing users of this API do not have to be recreated, recompiled, or changed in any way. And you should, with your enterprise services and your IO services, you should adopt exactly the same policy. There's a consistency there, and you need that consistency to allow your developers to be comfortable. Okay, there are numerous different ways of defining and utilizing enterprise APIs. This is a list type API which lists multiple occurrences of information out of a file. You might have a retrieve API, which has a receiver variable because it only receives a block of data and not multiple iterations of data. You'll notice that in this case, the receiver variable has a character char star, which is typically means it's a variable length variable, and it's defined, its length is defined by the parameter just before it, which indicates how long this receiver variable is in this circumstance. You need, when you get into enterprise services, you need to have a look seriously at the API manuals. We will talk, there is a section on APIs later on in this course, which we can then deal with, and I will go into APIs in a lot more detail. But your enterprise services are that final boundary between your database, it sits on the fence between your database and your application code. Okay, I'm not going to do more than that in this case. These are much more the content, the concept, and the function of enterprise services are more defined by the application than the database. And so you need to look at them and decide what services are going to be provided. And you don't have to just provide services that are used more than once. You can provide services that you think may be used more than once. And then if they are, you score extra bonus points. All right. So that is really what brings us to the end of the physical database. We're now going to, for the rest of this session, we're going to look at the logical database, unless you have any questions, which you can shove through to me. Why is this giving me so much trouble? Why is the chat box? Okay. So if you would like any questions that I can answer about anything that I did from the beginning, now's the time, because remember that I am going to be gone for 3 weeks, and so there will be a gap of 6 sessions. Give you a break from me, which I'm sure you will be grateful for. I won't get much of a break because I will be in Wisconsin for the first week. And if any of you are going to be at the Wisconsin Spring Conference, which is from the Tuesday, where's my calendar? Tuesday the 14th through the 16th. I'm going to be arriving in Wisconsin at Delavan on the 12th, Sunday afternoon the 12th, and I will be leaving sometime on Friday the 17th. So if you happen to be there, please look me up, and I would very much like to meet you and have any sort of conversation with you that you like. So that brings us to the end of the physical database and its modernization. Now we are going to move on to looking at the viewing of the data store. Remember, the physical database, now of course with its referential constraints, its triggers, its I/O servers, and even its enterprise services, has now become hugely intelligent. But nevertheless, we do need to have views of the data other than the physical views presented by the physical data files. Because the physical data files have been normalized and created to optimize the DB2 relational database. They are not normalized and created to optimize the developer's requirements for creating an application. And that is true across the board. That is why we have the ability to create logical views of that data so that we can align the data to be more application friendly rather than relationship and database friendly. And that's what the database, the logical database, is actually used for. The physical database consists of DDS physical files and DDL tables. Those are the only two types of objects, together with, of course, their constraints and triggers and I/O servers. They make up the physical database. They, as we discussed before, have a definition, a data member, an access path, and authorities. That's how a physical file looks. The logical database is made up of, now this is where I can have endless discussions with people about what is what and who is who. Years ago when we started, and right up until quite recently, DDS was the only manner of describing logical database views. And there were three things you could do. You could define and describe DDS views, which was a one-on-one relationship to a physical file. It allowed you to change the viewing sequence. It allowed you to change the record content. It allowed you to concatenate and substring variables so that you could look at one single physical file from a different sequence with a different number of records. That was the DDS view. That was the DDS view. Then we also had the ability to join more than one physical file together. In fact, at one point in time, the maximum allowed was 64, and then it became something bigger than that. And I know somebody told me what it was supposed to be, but I can't remember now. You can join quite a few files. And what you get is you get a single file that contains information from multiple files. And that is a non-updatable data path. So the DDS joins, you cannot update.
No.
Hello, Matthew. Did you say no? Joins you cannot update directly. There's no update function on a join. And this is where your I/O servers kick in. You can make a DDS join updatable simply by writing it into your I/O server. I/O server can hide the fact that it's a join file and just update the individual physical files whenever you require to do an update or an insert. So you can make it invisible, but strictly speaking, the DDS joins are not updatable. Then you have a DDS multi-format. I call it a multi-format. The manual calls it a non-join logical, where you can structure a file over multiple physical files, where each physical file actually consists of a record format, a separate record format. It actually takes us way back to those old days of the System 36, when we used to have record type code, record types in the file, and we used to read the file and determine its type, what was in the record, by its type code. That's a DDS multi-format. There's more to it than that. It can be sequenced so that the files are merged together in a particular sequence. Certain records can be left out of each file. And of course, things can be substringed and concatenated within each format. So it's a highly functional form of logical view over the database. It does, I have to admit it, and I have been bitten by it, it does require a lot of resource to maintain the non-join logical access paths. As a result, it can present itself with a little bit of overhead. But that often outweighs its functionality. Right, those are the three old ones that we have with DDS. Then, of course, along came SQL. And we got three new ones. Logical database. The DDL EV index, encoded vector index. That is very similar to the DDL BR or binary Radix index, except for one thing. The EV or encoded vector index, you can't read, you can't view, you can't do anything with it. It is there specifically and only to improve the performance of SQL queries. And you can create encoded vector indexes that will significantly improve the performance of SQL queries. But you can't, they are almost hidden. You can't define them on an S-spec, you can't do anything. They work with the query optimizer to optimize the thing. The rule with encoded vector indices is the more individual key fields you have in the path, the slower the index becomes. So if I have an encoded vector index with one field, on the index, it's very fast, and it improves the performance of queries around that particular field. If I have 25 fields in the index, it's a dog, and you don't want to go there because of the mechanisms inside the encoding. That the more fields there are, the more vectors you have, and the search through the vectors takes longer and longer and longer. So I'm not really going to worry too much about that. It's used to speed up SQL performances, and the index advisor, which we can look at later on, will actually tell you when it feels you need an EV index, an EVI, in order to improve the performance of a query. But, and this is the important thing. Well, let me first of all talk about the BR index, the binary Radix index. This can be used to create an index on any file in the database. Any physical file in the database. Whether it is a DDS physical file or a DDL physical file, it does not matter. And I'll stress this again, please understand, when you're looking at DDL logicals, it doesn't matter whether they're built over a DDS old-style ISAM type physical file or a new SQL type table. They will still work. The performance will be slightly different because it is the base table, and if it's a DDS ISAM type physical file, the BR index won't work as fast as if it is a proper SQL engine physical table. So it's the underlying files that determine the performance of these logicals. But BR indexes are indexes that are built over physical tables, and they can also be, in fact, they must also be built over DDL views. Because a DDL view cannot specify a sequence, a BR index specifies a sequence and a record selection, a where clause and an order by, or an index. The DDL view cannot specify an order by. Now, the DDL view is a SQL construct that allows you to put a view over one or more physical tables or DDLS files. Doesn't matter. As far as the IBMI engine is concerned, it doesn't matter whether the physicals are DDL or DDS, you can still do this. This puts a view over one or more physical files. And in fact, I believe, although I've never tried it, you can also include other DDL views in that particular construct. It is also not updatable as a data path. And you can't provide it with an index directly. You have to use a BR index over the top of the DDL view to provide sequencing for the DDL view. Right, now here comes the interesting part. None of these 6 options replace, or put it this way, none of the bottom 3 options are directly compatible and directly replace any of the top 3 options. The closest is the DDS view and the BR index. Those two are pretty close and can be interchangeable. The joins, DDS joins, are 2 or more. They can select records. They can also sequence the file, and therefore they are similar to the DDL view, but they are not interchangeable. You cannot just take your DDS joins, create DDL views, and hope your programs are going to work. They ain't going to. The DDS multi-format has no SQL equivalent, and the DDL EV index has no DDS equivalent. So one of the things one must understand about the logical database that we have now as opposed to the one we had before is that where we had 3 options before, we've now got 6. And that doesn't include embedded select statements inside your RPG. These are predefined logical views. So the number's gone up from 3 to 6. And as a result, when we built AO, I did not change any of the logical DDSs to DDLs, because there was no way that that could be done without changing the level IDs. And as a result, AO does not recreate any DDS logical as a DDL. They remain DDS. If you want to create it as a DDL, you have to create a new file because they are not simply replaceable. I can't stress this enough. Too many people think that, oh, I'm going to go to DDL and SQL and I'm going to throw all my DDS out, including my DDS logical files. Don't do it, because actually there are many cases where a DDS view or the multi-format function is a better option than what SQL can provide. And the big thing here to understand is I can recompile my DDS files. Let me see if I can find what I'm looking for here. Yes, here we are. If I use the create logical file command, which is for DDSs, and I prompt it, and press F10 to get more parameters, Here, access path logical page size. I can recompile my DDS logicals so that I can jack up the page size from the default it used to be, which was 8. I can jack it up to 64, and actually I can take it beyond. I can take it to 512 bytes, 512K logical page sizes. So even if your logical file is a DDS logical, if you recompile it to a bigger page size, which, by the way, does not change the level ID, you get better performance out of it. And if your DDS file is now based on a DDL table, actually, even though it's defined using the DDS source code, it actually has the same performance as the DDL files because it's based on a DDL table and therefore uses the SQL engine to process the logical file. So as long as your physical tables are changed from DDS to DDL and you recompile your DDS versions up to a higher page size, there's no difference. What you have is you've got 6 options now instead of the previous 3 you had before. So don't go changing your logical database at random because you believe you have to get rid of the DDS. Just recompile them with a bigger page size and make sure they're attached to a table and you're away. Now let's just have a look at the definitions for logical files. A logical file, when you compile it, has a definition, exactly the same as a physical table. It has an access path, which is defined for everything except the DDL view, and it has authorities. What it is actually missing is the data member. A logical file has no data member because the actual data resides in the physical tables themselves. But again, a word of warning. Although this might appear, whoops, I got no data member, therefore logical views will tend to be smaller than my physical files. Don't be too fooled by that. I have actually seen logical files defined that physically occupy more bytes on disk than their matching physical data files. Because, of course, the access path includes record selections, keys, all that sort of thing, and, of course, pointers to the physical record. So the more complex your logical file is, the bigger the access path build is, and therefore the bigger the number of bytes of physical data space you are using, disk space you are using. So don't fall into the trap of thinking, oh, I'll create a million logicals to look at my database every which way, only to find that actually it's sucking up so much data space, disk space, sorry, that it's not practical. And the biggest danger I've come across in the past is having people create high volume, complex logical views and logical files over physical files that are used for a year-end batch processing job. So what's happened is that they are annexing a large chunk of available disk space to house the definition, access path, and authorities for a file that is used once a year. It's better in that case, and this is where SQL comes into its own, and where the query file, the open query file, which was the predecessor of SQL, I used to plug it like crazy, is that for logical views that are needed infrequently, don't create permanent logical files. Create permanent logical files to support high performance on interactive environments. That's where they really come into their own, where you can pick up information quickly because they are permanently defined. And you will find that they actually become very much into play when you start defining your enterprise services. You will start to generate logical files to service your enterprise services functions. But never create a permanent logical file, particularly a complex one over millions and millions and millions of records. If you're only going to use that file once a month or once a year, it's better to sacrifice the build time at the time you want it than to waste the disk space. And remember, when you build logical files that are huge and massive, they get backed up. Every time they get backed up. They get backed up. Yes, they're changing. They also have to have their access paths maintained. So if you have a file built into a logical view, logical index that is dynamic, the operating system has got to maintain that access path at all times, regardless whether that file is used 20 million times a day or once a year. It still has to maintain the access path. So you need to look at that in terms of overhead. All right. Let's have a quick look at the construction of some of these files. I've got some pictures for you. Right. Let's have a DDS view. Let's just be quite definite about a DDS view. A DDS view is a viable construction going forward into the future until IBM withdraws support for DDS. Somehow I don't see them doing that, but you never know. A DDS view is a perfectly acceptable structure if it is based on a DDL table and is compiled with a 64K page size. It is equivalent to anything that DDL can provide. So don't get rid of them, and don't be scared to even define new ones if you need to in terms of the modernization of your database. I have, by the way, in writing twice that a logical file using DDS built over a DDL table performs as well as a DDL file built over the same table. I checked that with the labs, and they repeat twice. They confirmed it. The third time they told me to stop bothering them. So I did. That's the DDS view. Right, let's have a look at what you can do with a DDS view. You can select specific and certain records out of the physical file, i.e. you can create a logical view with a subset of the records. You can alter the sequence that you process those records in using a logical file. I want to say something here about this. It applies to all these logicals that have sequences or keys. One would think it's counterintuitive, but the key of a file does not form part of the level ID. Be very careful of this. If you change the sequence on a logical file, it doesn't alter the level ID. Therefore, a program that has been written for that over that logical file can continue to process. Only it will process the records in a different order. And that can cause severe problems. When I found this out, I was actually quite surprised that the key itself doesn't actually impact the level ID of the file. What else? You can select fields. That is known as an explicit logical, where you explicitly define only certain fields that you want included in the logical file. You have to specify a record format name that is different from the record format on the physical data file, and you have to specify explicitly the names of each field that you want included in that logical. Now, it's a good idea when you're designing access to the database, or you want to provide access through, if your database architect, your database engineer wants to provide a specific type of access to the database for applications, to make sure of which records are required, what sequence is required, and specifically what fields are going to be used, because it is better to customize the file to suit the need. Smaller number of fields, reduce the size of the file. Smaller number of records, reduce the size of the file. You are not processing or storing unnecessary records for that function. But again, a word of warning. This is a pendulum situation. You can swing too far either way. If you go too far to the customized logical side, you might find you are creating a huge number of logicals for very specific purposes, and therefore you are again sucking up disk space unnecessarily. So you've got to find the central position for that pendulum when you start doing this. Okay. And you can derive fields. That's by explicit definition as well. You can concatenate two physical file fields into a single logical field, or you can split a physical file field into multiple logical file fields. And you can rename fields. Why you would do that, I wouldn't know. It doesn't make any sense to me to have a logical view one-on-one over a physical data file and change the name of the records. I did have one example. Let me finish this. You can also reorder fields, i.e., you can change the order of the fields in the logical file to be different from the physical file. Those are the things you can do with a logical file, DDS type view over a physical data file. I found a circumstance where a logical file had been created over a physical data file, and all the fields included in the logical file had been renamed. So the logical file had fields where every field had a different name from its matching field in the physical file. Wasn't quite sure why, but then to my horror, I discovered that the key of that logical file, the sequence of that logical file, was defined using the field names, not the renamed field names as they appeared in the logical file, but the actual field names as they came from the physical data file. I couldn't believe that this was even possible. I actually had to go and create an object like that myself in order to prove that you can actually do that. You can rename your logical file fields, but sequence it using the names from the physical data file. Now, it's a good way. It's a good way to really confuse people when they're trying to do maintenance on your application. And honestly, I would recommend you don't do it. Please. All right. Right, how does this fit in with our concept of I/O servers, etc., etc.? This logical file has an updatable open data path, ODP. Therefore, I can have an I/O server for that logical file, and of course I would have an I/O server for the physical data file, the PF data. So I've got two I/O servers that I can access the physical data file and or the logical data file, both updatable. So that is the construct, and using I/O servers, the access to a DDS view. And that's what you can do with it. And you will see as I go through these that it's very clear that there's a lack of, there's no commonality between any of the six. And therefore you must choose to use the one that is most appropriate to what you want to do. Right, let's move on, unless there are any questions at this point in time. Obviously, if you disagree with anything I say, you've also got to tell me about it. Because I will then backpedal massively. Right, let's have a look at the DDS joins. DDS join is a logical view which takes files. I don't know, there were 64 at one stage, there are probably 3,786 at this point in time, I don't know. The best I've ever done, I think, is 8. Beyond that, you're getting a bit hairy anyway. The first file you define is the primary file. And subsequent files that you define in order 2, 3, 4, 5, 6 are secondary files. Right. Then you specify a single record format to create the logical file. So essentially, your join logical creates a file with a single record format that contains fields from any one of the primary and one or more secondaries. You first have to specify how these files are going to be joined, i.e., on which fields you are going to make the join. And here again is another advert for sanitized data dictionaries where you're using the same field names across files, because then it's easy to identify which fields match with which fields and how you're going to join them. This particular format is always an explicit format. That's fairly logical, because you're always defining fields from multiple files. So you have to be explicit about which fields you are putting in. You can select records, but only from fields in the primary file. You can't do a selection from fields in a secondary file. This is where this is not quite as good as the DDL view, because the DDL view allows you to select records from fields in any one of the files. Here you can only select records from the primary file. So you have to be careful here which file you define as the primary. Change the sequence, i.e. you can reorder the records in the logical file, but only using fields from the primary. Again, only from the primary. But in this particular case, the DDL view doesn't have a sequence. So this is actually better than the DDL view because I can actually change the sequence, even though it is only from the primary file fields. I can select fields, and I can select fields from any one of the joined files. I can derive fields in the same way as I can derive from the DDS view. I can derive in this logical. I can rename fields in exactly the same, and quite often in this case you do need a rename, because if the same field exists in two files and you want both those fields in your resulting logical, then you're going to have to rename one of them, because obviously by definition you can't have two fields with the same name in the same file. That's a conflict. So in this case, you do need to rename one of them. If it's one of the fields you're joining on, of course, you don't need to do that. You leave it out because they must contain the same value, otherwise you wouldn't be joining on. Reorder fields. The order of the fields in the logical file you determine. And that depends entirely on which fields you're pulling out of what files and what you want the program to see as the field order. Remember, one of the rules, COD's rules, is that there should be no intrinsic, sorry, it's a normalization rule actually. There should be no intrinsic value in the sequence of the fields in a file. So sequencing fields in a file is purely for aesthetics more than anything else. Right. When we add the I/O server, what we have here on this logical file is a non-updatable open data path, i.e. I cannot directly update this logical file. But what I can do is I can create a I/O server that allows me all the read functions for that logical file, no problem. If I wanted to make this logical file appear to be updatable, I would simply utilize this I/O server. Hang on, I must really just get my pointer options. I would simply utilize this I/O server and other I/O servers, one for each of these files, 1, 2, and whatever else there is, so that this logical file would appear to be updatable, but in fact it's using the physical file I/O servers to achieve the update. And of course, an update on any one of these physicals will immediately, on commit, represent in the logical file. So if you did that and updated, if you made this an updatable open data path, you would actually be doing that. And when you then read the record back again, it would look like it had been updated. And that's a great tool, because it means that your applications can design files, have the files designed with joins in them, and your developers can update them in the same way as they update other files, which makes everything a lot more consistent. Okay, that's DDS joins. The resulting record is in fact a single record format, and you read it one record at a time. No matter how many physical files you've got joined, the result is a single record format. Any questions? Multi-format logicals. Now, at first I thought these weren't terribly common across the database, but subsequently I've realized that actually they're used quite a lot. Again, some of them are used in strange ways, but what these are is a merge. Essentially, it's a merge. You create from multiple physical tables, you create a file that contains records of different record structures based on the physical file. So I can have a record structure based on file 1 and merged with a record structure based on file 2 and 1 and 2 and 1 and so on. You're merging these two together. If you have 3 or 4 physical files, you can merge those together. You can specify keys to control how they merge. You can even use null keys because some files may not have fields that allow you to put them into keys. And so you merge them together. And then when you read the file, you've got all the records that you want in the order that you want them. So you can process a single file to produce, I don't know, an invoice run, because the records are all merged together, customer followed by header, followed by detail, followed by whatever. They're all in one file. What this does is it reduces your I/O, which improves your performance tremendously. Let's see what you can do with this. I can select records, i.e. I don't have to select all the records. I can change the sequence. Now the sequence I can control per physical record type. So that's how I use the change of sequence and the sequence control to merge the records the way I want them. I can select fields. I can select fields from file 1, and so record 1 here would have some fields, and record 2 might have a subset of the fields from file 2. I can choose which fields are going to be in each one of those files. I can derive fields in the same way, concatenate substring, etc. I can rename fields. But in this case, again, like with a view, it doesn't seem to be sensible to rename the physical data files because they are in their own record format. And then the last thing is I can reorder the fields in each record type to suit myself. Again, same comment applies. There doesn't seem to be much point in reordering the fields as it's a semantic. Now, this multi-format has an updatable open data path. Data path is updatable. As a result, I can have an I/O server for it, and my client can update either or one or more of these physical data files through the I/O server without a problem, because the record type is linked to a particular physical file, so that's what makes the data path updatable. Okay, those are the 3 DDS formats. Any questions at this point in time? Okay, encoded vector index, EV, or EVI, as it's commonly known, is a physical, it's a logical file over a physical data file. You can select records. You can change the sequence. You can select fields, i.e. you can be explicit about what fields you're including in the EVI. You can derive fields. You can rename fields. And you can reorder fields in the EVI. And that's it. You can do nothing else with that file. You can't read it, you can't write to it, you can't update it, you can do nothing. It is used by the query optimizer, and only by the query optimizer, to improve the performance of SQL statements, either embedded SQL or other SQL queries that are run on the system. My advice is never build them unless you have a problem with performance and you look at the inspector, the advisor. I'll show you the advisor just now. Don't build them. They can be a lot of clutter, and you might find, in fact, that you make matters worse rather than better. So build them only under certain specific advice. Right, let's look at the BR index. This one is very similar to the DDS view. It's a logical file or logical index based over a physical data file. And you can select records. You can change sequence. You can select fields if it's an explicit definition. And once you select fields, you have to select all the fields that you want. You can derive fields. You can rename fields. And you can reorder fields. So what you can actually do with this particular file is almost identical to what you can do with the DDS view. This is the only one that is interchangeable for the most part with one of the DDS definitions. So in my opinion, when you want to create a view, a new view over your database, you might as well, in the spirit of modernizing, you might as well create it as a DDL BRI rather than a DDS view. This data path is updatable, so the I/O servers will operate in exactly the same way as they do for the DDS view. As a result, sorry, just taking some water. As a result, these two are the only ones that are really interchangeable, and if you've got new indexes, do them using a BRI. But don't go back and change all your existing DDS ones to BRIs, because there is one big difference. And any change of an existing DDS view to a DDL BRI will cause a level ID change. And that means you're going to have to go and find all the programs that use this logical, and you are going to have to change it, to recompile them. And the reason that this will cause a level ID change is that the order of fields in the file changes. When you define the sequence, i.e., the order in which you want to see the records, the create index function takes the fields that make up the key and places them at the top of the record. All the other fields that don't make up the key are then placed after those in order. And that creates a problem, because immediately you change the order of fields in a file, you change the level ID, and therefore you have to recompile your programs. So my recommendation is don't bother. New ones, yes, go for it. It's not a problem. But the existing ones, keep them as DDS. And only if you're doing a major change to that particular part of the application or that section of code, you're actually making a change, then you're going to have to recompile those programs anyway. Then you might as well change the logicals to BRIs. But other than that, you're not going to gain much. Okay. DDL View. This is some equivalent to the DDS join, in that you can join multiple primary and secondary files together by specifying join criteria based on fields. Just excuse me one sec. Sorry, I have a fan going in here, but it's now getting a tad cold. So I needed to stop myself freezing. So here you have the ability to join multiple tables together into a single record view. And what you can do is this. You can select particular records. Those are records based on the result of the joins. So you don't have to include every record that joins. You can select fields, i.e. you can select fields. This whole thing is explicit, by the way. You can derive fields, you can rename fields, and you can reorder fields. Notice the one significant thing that's missing there, oh boy, is you cannot change the sequence of the records. There is no way in your create DDL view, your create view, to define the sequence of the records. If you want this view to be processed in a particular sequence, you have two choices. You either create a DDL BRI index over this logical file. It's the only circumstance in which you can create a logical file over a logical file. Or you can embed a select clause out of this logical file into your RPG program and provide the sequence at the time of execution. However, remember that carries an overhead because the access path has to be built before it can be used, and therefore if it's an interactive process, it could create unacceptable delays. So if you want to build a predefined logical DDL view, which you want to access in a certain sequence, you have to build a BRI over the top of it. What is nice about it is you can create a view, and then you can have 16 BRIs, all accessing the same logical file, but providing different sequences over the file. That's quite useful. Depends on how you've designed your database and what you want out of it. But it's a space saver, it's a time saver, and so on and so forth. Okay, this is also a non-updatable ODP. Can't update it, therefore the logical file has to do the same game as we were talking about before. If you want to make it a two-way street, you then have your logical file using the physical data files, however many there are, in order to do the changes, updates to this file and to that file. And of course, the reads are done direct from the logical file. So you handle this from an I/O server perspective. You handle it in exactly the same way as you do the DDS join. So again, there are similarities between the join and this view, but they're not the same construct. They have anomalies, which means that they're not interchangeable. And you need to choose. You used to have 3, you've now got 6. So basically what you need to do is you need to choose the one that most suits what you need it for. And later on, if you decide a DDS join or multi-format is what you need, then use it. Please don't fall into the trap of believing that you have to create DDL views because you're a DDL shop. The DDS is workable and it's been around a long time. And if it's based on SQL Engine, it's also quick, has a bigger page size, everything is fantastic. So those are the various views you can construct over your database. Now, when I run AO Inspector is a free product, it's downloadable from the website, that actually analyzes the objects in a database or set of database libraries. And it counts the physicals, it counts the logicals, and it sort of gives you all sorts of numbers showing what's good and what's bad and what's indifferent. However, the most interesting number that I find in the inspector is the logical to physical file ratios. And it's quite extraordinary how much that can tell you. I have found ratios in some databases of below 1.4, i.e. there are many more physicals than there are logicals. Now that tells me one thing. It tells me that, in fact, people are using the logical files to access using the physical files to access data, and they're not using the capability that the logical files have to provide you and prepare data up front for processing. I also have seen databases where you've got 25 to 1, 25 logicals to each physical on average. Now that is very, very high. Extraordinarily so. And what that means is that you're using up a lot of disk space and maintenance overhead, which translates as a performance killer, to maintain all these logical files. And in a situation like that, I had one, and I found dozens and dozens of duplicate logical files, genuine duplicates, same physicals, same keys, same selection, same everything. And that happens, unfortunately, when developers are pushed. They need a logical. They haven't got time to go and look and see what's there, so they create another one. The best sort of average, and really this is a thumb suck. I can't even say to you that it has any basis in science, to be honest. But the best operating databases with the least problems that I've come across have a logical to physical ratio of between 3 to 1 and 7 to 1 on average. That still doesn't prevent one particular file from having 45 logicals. You need to drill into that. But I find lately that people are using far too few logical files. They're relying on SQL and embedded SQL to do logical processing instead of creating predefined logical files. And the disadvantages of that is performance, which means every time that you want an alternative view of the database, you have to create the access path. It was fine in the old days when disk was hugely expensive. So what we wanted to do was to save disk, and the performance wasn't so critical because a little bit of extra minutes to create an access path didn't kill anybody. Nowadays, the tables are turned. Disk space is becoming cheaper and cheaper and cheaper, and people's expectations Okay, Matt has given me a nice phrase. I'm going to put this, Matt, in one of my presentations. Pay me now, pay me later. Unfortunately, this is life in this business. It's always a trade-off. Always a trade-off. There's no one perfect solution to any situation whatsoever. Yeah, this is true. There's no one perfect solution to any situation. It's the pendulum thing all over again. In one instance, it's ideal, but you're paying a price in one area, you go the other, it fixes that up, but it costs you something in this area. And generally, all the solutions in IT, and being OCD myself, I have a big problem with this. All the solutions in IT generally end up to be middle-of-the-road compromises as the best solution. So one has to bear this in mind when you're building your database, your physical database and your logical database. You have to look realistically at what you can trade on one side against what you can trade on the other side. Matt has just made the comment to me that too many logicals are deadly on index maintenance. He's right. If you have too many logicals, particularly if they are based over a volatile transaction file, you don't even see the cost of that because it's actually background maintenance on the access paths. But it does cost you CPU cycles, and that you pay for in performance. So it is a trade-off, always a trade-off. And I've never, ever found a solution that's 100% perfect without having to give something away on the other side to make it practical. Perfect solutions generally tend to be impractical, and practical solutions tend to be imperfect. And I'm sure you all, okay, that one, Matt, I don't know. I can't work. Matt has written T-A-N-S-T-A-A-F-L, but I can't work that out. It's cryptic. Maybe somebody can spell it out for me. Oh, okay. There ain't no such thing as a free lunch. This is true. And it's one of the things that is really a problem, because when you get multiple people, and I know some of the people here have got largish development environments, and some of the people will do things one way because that's the way they feel comfortable with. Others do it another way. I've just finished the preparation for one of my presentations at Wisconsin. And on the last slide at the bottom, I've got a question there which says, is programming an art or a science? And that the jury is still out on. A lot of programmers think it's an art, and therefore they use artistic license and they can get away with just about anything. That doesn't lend itself towards good modernization practices. But there again, the scientists are too rigid, so that the flexibility that you need to build into your system is eliminated. So I'm afraid most of this gets to the point where there has to be somebody who actually lays down the law, makes sure the rules are followed, and that things are done according to a plan. Guys, fortunately, I've basically got to the end of what I was dealing with. The next section switches on to programs and procedures and development, modernization of actual application code. But we're heading here for a bit of a storm. It's black and it's blowing and it's looking ugly. So I'm going to ask once more, are there any questions that you can think of at this point that I can answer? because the next topic is RPG4 for the integrated language environment. Okay, so this particular session, bit short, but I'm not going to begin, because we have a 6-week break now, I'm not going to begin on the RPG4 modernization topics, because that would just mean that in 6 weeks' time I would have to actually start all over again. So I'm going to let you go a bit early. And again, if you happen to be in Wisconsin next week, look me up. I would really like to speak to you. And other than that, have a great day. Our next session will be on April the 4th. Oh yes, Dean. Dean, are you going to be at Wisconsin? Okay. All right, then as soon as I get back, what I'll do is I'll contact you and we can talk about what we discussed last week as sort of a offline session to answer some of those questions you had specific to your environment. Okay. Good. Thank you, everybody. And have a good day.